Now we're on. We're good. Let's move it over here a little bit. Over here. There we go. Okay. Today, as I said, oh, I hate the thin marker. I despise that. What color do you guys want me to write with today?
Blue, green, purple, purple,
Purple one. Oh, Here we go. Circuits. Today we are talking about circuits. So let's define what a circuit is. So a circuit, I would call it a complete path. A complete path for what? Electricity. For electricity to flow. A complete path for electricity to flow. I like that. And it is represented, it's represented by anyone know what it's called, what we draw for circuits?
circuit board.
Schematic diagram. A schematic diagram. It's represented by a schematic diagram. So let's talk about symbols you may see on a schematic diagram. Symbols. Anybody have a symbol you may see on a schematic diagram? Plus.
Minus.
What about this? What if I did this? So negative. No, let me draw that again. You know what?
Perpendicular.
What would that symbol be?
Minus negative one. Positive. Battery.
Battery. Nice. That's a battery. That's a battery. What else may you see on a schematic diagram?
Wait, so what is charger disconnected from it?
Well, that's negative positive. Just negative side, positive side. X.
Marks the spot.
No.
Closed.
Oh, okay. What would this be?
Closed.
Closed circuit. I like that. A closed switch. All right. That could be a closed switch. Closed switch. What about this one?
Open.
Be an open switch. Now our brains are warming up. Open switch. What'd you say, Olive? Wire. This is a wire. Straight line.
Did we ever get to work on those, like, you know, those boards you got when you were like...
Tomorrow. So we're doing tomorrow. Tomorrow we're building circuits. That's our lab, yes. Tomorrow we're building circuits. What about this? Squiggle.
Conductor,
Not a conductor.
insulator,
Not an insulator. A resistor.
what is that?
Well, a resistor is something that resists electrical flow. All right? So that could be like a buzzer, or if I would redraw it like this, what's that?
Insulator.
A
No.
resistor in a circle.
An egg.
Closed resistor?
Different.
Complete resistor.
What does that look like?
A frowning
An egg
face
cracking.
with
An egg cracking.
eyes? Yeah, got that.
It's a light bulb,
Oh!
right? There's the filament
I see it.
in a circle of glass. That's a light bulb. A light bulb is a resistor. The light bulb resists electricity to flow through it, therefore it gets bright. It gets bright. That is a resistor. Closed switch, open switch, wire resistor, light bulb. What?
That's an egg.
Well, yeah, it kind of looks like that too. I think that's pretty good.
Doesn't an insulator also resist electric flow?
Yeah, but it's called a resistor. There's two types of circuits. Anybody know what one of the two main types of circuits is? One is called a series circuit. Have you guys ever heard of this before? Okay. I don't know if you did some of this in 8th grade or not. A series circuit is where voltage is divided evenly, among all resistors. Among all resistors. The problem with the series circuit is there is only one path. There is only one path for electrons to flow, which means if something is a series circuit, if one goes out, guess what happens? They all go out. A classic example is your Christmas lights. Actually, we should put Christmas old, put in parentheses, old Christmas lights. Because new Christmas lights don't do this anymore. All right? So Christmas lights that are old, if one went out, they all went out. You guys remember Christmas Vacation? National Lampoons. Have you guys ever seen that movie? All right? Yeah. Gets them all balled up. He has to check every single light bulb, right? Now, you don't have to do that as much. So a series, that's the problem with series circuits. If one goes out, they all go out. So let's draw what a series circuit might look like. So let's do a battery here. So here's a battery. So here's a negative side. Here's a positive side. And this battery, do you guys want to draw it with, let's not even draw a switch. Who farted?
Archie always does that.
This would be a series circuit because this would actually be a series circuit with a closed switch. So would you agree there's only one way for electrons to flow? Yes? If I cut a cord, is there anywhere for electrons to flow? No. If this light bulb burns out, is there anywhere for electrons to flow? No. Because the electrons have to flow only in one path. That is a series circuit. Makes sense. Head nod if you're good with that. Okay. What's the other type?
Blue. Parallel circuit.
Parallel. Nice, William. The other one is a parallel circuit. P-A-R. Is it one R?
I think so. Then.
P-A-R-A-L-L-E-L circuit. A parallel circuit is the other main type of circuit. This is where the voltage is the same. So the voltage is the same across all resistors. The voltage is the same across all resistors. So this means there's multiple paths. There's multiple paths. It also means if one goes out, guess what? Others stay on. The others stay on. Would you want your kitchen to be wired in series?
No.
No. Why? If my toaster goes out, what else is going to go out? My refrigerator, my oven, my dishwasher, right? I want my kitchen to be wired how? Parallel. And that's how your house is wired, right? And we'll talk about the safety on those in a second. So let's draw a parallel circuit. So let's draw our battery again. So here's our negative side. Here's our positive side. Here is what a parallel circuit looks like. That is a parallel circuit with 3 light bulbs. This is a parallel circuit with 3 light bulbs. And notice, how do the light bulbs look to each other? They look like they are parallel, right? Do they have to look parallel exactly like this? No, but that's how I like to draw them. Yes?
So can wires just like go forever?
Wires?
Yeah.
If there's enough voltage to start, sure.
Like, it would just keep going all
Yeah.
the way down the wires?
Yeah.
Okay.
Now, if the wire cuts here, ooh, that's not what I was trying to do. If the wire cuts here, I don't want to move the screen.
Fist.
You're wrong.
You know what?
Too much knuckle. You were using too much knuckle. You gotta do more fist.
If the wire cuts there, can electricity go around that?
Yes.
Yes. If this bulb burns out, can electricity go around that?
Yeah.
Yes. So that is a parallel circuit. Okay. What is the difference between a fuse? Well, first of all, what does a fuse do? No, fuse actually does not start.
It's the big box that has electricity.
It's not the big box.
Controls the flow of it?
Regulates.
When I first moved into my house,
Yeah.
I kept blowing fuses in my air conditioning. And I'm not the handiest person, all right? So I would just go to the store. Fuses were like 33 cents. I just bought like 20 fuses, and every time one busted, I just put a new one in, all right? What were my fuses doing, though? Melting, all right? Fuses melt. Fuses melt. So my air condition kept overheating, and it kept sending too much energy through the wires. As soon as that happened, the fuse got too hot. The fuse melted. Why is that a good safety thing to have? The energy stops. Because if the wires get too hot, guess what's going to happen? They're going to catch on fire, right? So I eventually called an air conditioning place. I opened up my air conditioner, and guess what was inside of there?
Mouse.
A mouse nest.
Yes, I get it.
All right? There was a mouse nest in there. A mouse had chewed part of the wire, and he said it was close to actually catching on fire. Because the mouse had put a bunch of like dry stuff in there. If that wire would have got too hot, could have caught the mouse nest on fire and caught my air conditioning on fire. Luckily, that's outside.
That's not very air conditioning like.
I know, it's not very air conditioning like. But a fuse would be in something like your hair dryer or your phone or your any device that you don't want to overheat. All right? Because you want the fuse to blow before you ruin the whole phone, right? You want the fuse to blow before you electrocute yourself. That's what a fuse is. Not to be confused with a circuit breaker. A circuit breaker is the box that you have in your house. How does that work?
It turns stuff on.
It flips open. It breaks circuits. It flips open. How does a circuit breaker work?
Turning the power on.
Why would it break the circuit? Well, if there's an overflow of energy, right? If like lightning hits your house, right? If lightning hits your house, sometimes you flip a circuit breaker open. If your refrigerator is for some reason running too hot, it might flip the circuit open. Because once again, you don't want the wires to get too hot because guess what? It'll catch on fire. It'll catch on fire. So that is circuits. There is one little equation I'm going to give to you, which is power. Power is equal to current times voltage. Power is equal to current times voltage. Power is symbolized by letter P. Current is symbolized by letter I. And voltage is symbolized by letter V. PIV. Yes.
What's I again? Current?
Current. I put it underneath what each thing is. My V should have been a little bit farther over, but that's okay. Tonight, you are doing page 3 in the packet. So, let's add one more thing here. Let's add one more thing. Power is measured in what? Watts. Current is going to be measured in what?
Volts.
Amps. Amps. And voltage is going to be measured in volts. It's going to be measured in volts.
Put this on our equation sheet.
So I would put this on your equation sheet. P is here, I is here, and V is there. So you're doing page 3 of the packet tonight. Some circuit stuff, some math stuff. Some circuit stuff, some math stuff. You should be able to finish that within the period and have hopefully no homework tonight. So get that done. Sure.